All right, on to 4-4 here. And what I want you to do on this first one, number 16 here, is to write a ratio that compares the number of calories from fat to the total number of calories. So a ratio, I want you to express it as a fraction. So put a fraction bar down. Then the top should be the total number of calories from fat, and the bottom should be the total number of calories. Please enter that and then simplify that fraction as much as possible. I want you to pause it now and then look at the answer afterwards. All right, you should have gotten a ratio of 9 to 28 there. Now let's do it for 2 such granola bars. Let's say we had 2 granola bars. Our total number of calories from fat from eating 2 granola bars, if it's 45 for one, then it's 90 for 2 of them. And the total number of calories for 2 granola bars will be twice 140, because that's just for one, and we'll get 280. And if we reduce that, we should get 9 over 28 again. And it says, is the ratio of calories the same for 2 granola bars as it is for one? 9 over 28, 9 over 28? Yes, it is. And it really is, because it's the same ratio of calories from fat to the total number of calories, no matter whether you're eating one granola bar or 2 granola bars. It's still the same ratio. Okay. Is the following statement true here? This is 20. Oh, I can't even read this here. Okay, this says 20 over 110 equals to 2 over 11, so that's 110 there. Okay, is that following statement true? Is 20 over 110 equal to 2 over 11? Are both, and how can we tell? Well, if we reduce the 20 over 110 by dividing them both by 10, I get 2 11s. Are these the same? The answer is yes. Are both of the fractions in the same proportion? And the answer to that is yes. In fact, that is the concept that we're trying to get here, is that if there's a fraction equal to a fraction, and if that's true, then they have to be in the same proportion if they're true like that, if they are equal to each other. A fraction equaling another means that they are in the same proportion. Okay. Let's multiply them across diagonally. 20 times 11, we got 20 times 11, and we should get 11 times 2 is 22 times 0 is 220. And then 2 times 110, 2 times 11 is 22 with a 0 on the end there. So 2 times 110 is also 220. So it says find the cross products. Cross products means multiply them diagonally. We just found this for these two, it was 220. For these two, it's 220. Compare them. Well, they are equal. Are all cross products of proportions equal? The answer is yes, and we can use that to make our lives very easy, to help us solve a lot of things. So let's see, do the ratios 6/9 and 8/12, are they a proportion? If they are, this would be true, that they're equal. Let's find the cross products. What's 8 times 9? 8 times 9 is 72. What's 6 times 12? This one you might not have memorized. 6 times 10 is 60, plus 6 times 2 is 12. 60 plus 12, is that 72? Yes, so 6 times 12 is also 72. That means 6/9 and 8/12 form a proportion. They are equal. Can you guys go ahead and find their cross products, see if they're equal, and see if these other fractions that we have here are proportional, and then check to see if we have the same answers here. Please stop it now until we go to check. So now looking at the first one in A, the cross products both came out to be 20, so these two fractions are proportional. In B, one of the cross products came out to be 336, the other 224, so these two fractions are not proportional. And in C, both of the cross products came out to be 420, so these two fractions are proportional. So So this one I'm going to change to a not equals because it is not proportional, not equal. All right, moving on to the next page here. All right, so this one, we're going to use this whole idea of proportions to be able to solve something. What's really interesting about this is because we know there's an equal sign in there. That says that these are proportions and they are true. So if we know that, then we know that their cross products must be equal. Well, so in order to solve for x, there's for this one, this says solve x by finding how x is not by itself. How is x not by itself? It's being divided by 4. So how do we get it by itself? We multiply both sides by 4. So if I have x over 4 equals to 9 over 10, I multiply both sides by 4. In this case, I'll multiply by 4 over 1. And the 4's cancel out. I'm left with x here. 9 times 4 is 36 over 10, which is actually going to give me 3.6. 36 divided by 10 is 3.6. So x equals to 3.6, or I could reduce it as a fraction doing it that way. This one here, we're going to do this by cross multiplying. And what this is saying, again, if there's an equal sign, that means that these two are equal. I'm going to solve this a different way than I did this one. The same problem, x over 4 equals 9 over 10. But if we know that there's an equal sign between two fractions, then their cross products must be equal. So in other words, x times 10, which is 10x, must be equal to these cross products, which is 4 times 9. So 10x is equal to 36. Solve it for x now, divide by 10. And I get x equals to 36 divided by 10, which is, again, 3.6. So this one is solving by finding how x is not by itself, the way that you guys have learned from this class earlier. This is a new way, solving it by cross-multiplying. Now, these ones, I would like you to solve all of these by cross-multiplying. One of the things that you'll discover, this was actually, we could not do this one the old way where we said, how is d not by itself? Because d is not being divided by 7. It's actually 7 divided by d. So that won't work in this way. So we're going to have to do this one using cross multiplication. Again, multiply these two, put an equals in between, and then solve for d. Do that for a, b, and c, and then we'll stop the video now and you compare your answers. All right, so you should have had in the first one that d is equal to 10.5. If you left it as a fraction, 21 over 2, that's okay as well, or 10.5. Second one, b is y equals 85, and third one, c, n equals to 4.9. Okay. Please, if you have any questions, we'll stop right now to ask any questions, and then we'll go on to do the last problem. So, in this particular one, let's do a real application of this. A microscope slide shows that 37 red blood cells out of 60, out of is like a fraction, 37 out of 60. There's a bunch of blood cells in them, 37 of them are red, 37 out of 60 of them. How many red blood cells would be expected in a sample of the same blood that has 925 blood cells? Okay, so this one happened to be blood cells, and the top one happened to be red blood cells. All right, so we're going to set up a proportion. The proportions should be the same, should be proportional. If from the same kind of blood, if we only looked at 60 blood cells and 37 were red, we should expect the same proportion out of 925. Well, this one was out of 60. This one is blood cells out of 925 blood cells. What we don't know is how many red blood cells there would be. But we know they're proportional, so we can use that to solve for R. Again, once we have this proportion set up, we can cross multiply. 60 times R equals to 37 times 925. This is actually a good time for you to break out the calculator. I don't mind us using it for math like this. 37 times 925 is 34,225. And then to get R by itself, it's being multiplied by 60, so I need to divide by 60. So I take that answer and I divide it by 60, and I get 570.41 something blood cells, but how many would I expect to see in this sample? Rounding up to the nearest 1 unit here, this would actually round down to 570. So we would expect there to be 570 red blood cells. Okay, after you guys go over the homework and you take a quiz, then your homework is, sorry, here at the bottom here, these are your pages of your homework, 168 to 169, 1 to 5 all, 7 to 17 odd, and then also page 172, these problems right here. So that's your homework to work on after you're done with the quiz. Have a nice long weekend.